Lesson 8.5, Quadratic Equations with Difference of Squares. All right, in order to open up difference of squares, I'm going to first read you a story about the town of Sqauresville. Once upon a time, a long time ago, there was a place called Sqauresville. And on every April 7th, a special bus came down the hill looking for special numbers to take to Sqauresville. All of the numbers wanted to come, but the bus driver was only allowed to bring perfect squares. So, we need to find some numbers to get on this bus. We'll start first with the perfect squares. Now, hopefully you know the perfect squares are numbers like 1, 4, 9, 16, 25, and 36. All of these numbers can go on the bus. But numbers aren't the only things that also can get that are perfect squares. We can also have x squared, y squared, a squared. All of those are perfect squares. And we can also have combinations of numbers and letters, like 49x squared, 64 a squared, 81 y squared. And also keep in mind that not only is squared a perfect square, but other exponents, like d to the 4th, e to the 6th, f to the 8th. Any exponent that is even is also a perfect square. So these are all of the perfect squares. Okay? So only these things can get on the bus. So let's get them on the bus now. Okay, stay there, bus. On the bus, on the bus, on the bus. Everybody is on the bus. So, back to the story. Once the bus is filled, off it drove through the special gates into the land of Sqauresville. The first stop the bus always made was at Sqauresville High School. Here was the perfect place for all the squares to meet and make friends. As in all high schools, as soon as the squares got together, love blossomed. And a squared met b squared. And then love, and it was love at first sight. They were inseparable. They went to all the dances together, helped each other with their homework, and got along great. And on their book covers and on their notes, you would always find them writing a squared plus b squared. But it wasn't meant to be. And one day, it finally happened. They had their differences. They were not getting along, and they decided to break up. As they were sorting out their problems, they decided that they will always remain friends. And they would always remember the good times, why they fell in love, and the bad times, why they broke up. So remember, you cannot break up or factor a happy couple. However, if a couple is having their differences, you can square root the first, A and A. You can square root the last, B and B. and you need one plus and one minus. So if you have a happy couple, don't break them up. But if a couple is having differences, break them up. X and X, 9 is a negative 9 and a positive 9. The bad times and the good times. So only difference of squares can be factored. If it's a sum, you leave it alone because it's a prime. All right, here are some examples on the next slide. All of these are unhappy couples and need to be broken up. So above is the formula, and here are some of the examples. If you'd like to pause here and try these, this is a good time. All right, so x squared minus 64. X squared is x times x. 64 is a perfect square. Plus 8 minus 8. That's how you get a negative 64. 1 plus, 1 minus. Good times, bad times. X squared minus 121. X and x. 121 is positive 11, negative 11. Good times, bad times. 16x squared. 16 is a perfect square. 4x, 4x. 25 is a perfect square. Good times, plus 5. Bad times, minus 5. And the last one, 4x squared is a perfect square. 2x, 2x. 81 is a perfect square, so is y. Plus 9y, minus 9y. Good times, bad times. All right, and on the last slide, sometimes it's not going to be perfectly obvious that you have a difference of squares. In E, if you notice, we have a higher exponent this time, x to the fourth. But as I said before, x to the fourth, anything with an even exponent, is a perfect square. So x to the fourth will be x squared, x squared. Now, negative 16, 16 is a perfect square. So we have good times and bad times. Plus 4, minus 4. Now, if you notice, we still have x squared in our factors. So this one, because it's higher exponent to start with, 4, can continue. Now, x squared plus 4 is a happy couple. Leave them alone. However, x squared minus 4 is not a happy couple. They have differences. So that's going to be x, and negative 4 is plus 2, minus 2. So, if you factor once and you have a happy couple, leave them. But if you have a difference of squares, you can factor once again. So if you'd like to try F, you should try it now and pause. Remember, you're going to factor this more than once. So x to the 8th was x to the 4th, because 4 plus 4 makes 8. You add exponents when you times. 256 is 16. So plus 16, minus 16. Happy couple right here, but unhappy over here. So I'm going to leave the happy couple, and I'm going to break up the other part. X to the 4th is x squared plus 4, x squared minus 4. Now, happy couple, unhappy couple. So the x to the 4th plus 16, x squared plus 4, those are fine. but at the end I have an unhappy couple. X squared minus 4 is x and x. Minus 4 is a positive 2 and a negative 2. Now I can't go any further because I'm just down to a regular x. It's not x squared anymore. So that green is your final answer. Now if you look at G and H, you should notice that these don't look like perfect squares, but they are in disguise. Remember what I said in the last lesson? If you can divide, divide. So take a look at the numbers for G. Both of those can be divided by, that's right, 3. So divide them by 3. 3's cancel, and you get x squared. 75 divided by 3 is 25. Now what you have in the parenthesis here is an unhappy couple. So factor them. X and x. Negative 25 is positive 5 and negative 5. The good times and the bad times. Now if you think you can figure out the greatest common factor for H, go ahead and take care of that now. What can you divide by? So pause for now. All right, I'm hoping you divided by 2. You would have crossed out the 2's, and you would have gotten x cubed minus 25x. Well, that's not a perfect square. It's x cubed. But if you didn't notice, there was an x in both of these. So not only should you divide by 2, but you should divide by 2x. What this will do is take 1x away from x cubed and leave you with x squared. 50 divided by 2 is 25, and the x's cancel out. Once again, there's an unhappy couple inside this parenthesis. So leaving the 2x in front, break them up. X plus 5 for the good times, and x minus 5 for why they broke up. And that's the end of factoring difference of squares. Hope the story was helpful.